Right, so today I'm supposed to talk about the commoditization of technology primarily for the 3D laser scanner space. Right, so I'm representing FARO, and hopefully I can give you some insights about this topic. Okay, first, some of you have already seen some of the speakers earlier today talk about FARO, laser scanning, and so on. I'm sure there'll be so some of you or some of us here that may not be so familiar with FARO. So let me just give a very quick, update of what FARO is. We have a US company founded in 1981 and has been listed in NASDAQ since 1997. Today, we started operations in US under one company, one office, and today we are actually a global company. Range of products doesn't only for the laser scanners, we also do products for the metrology line of range of business. So I think, right, what you see below there, right, we actually have a company that provides a range of service, 3D portable measurement services, and imaging solutions that are actually disruptive in pricing, features, and design. Right, so I'll get back to the word disruptive later. All right. Okay, so here we are all of us is part of the whole geospatial environment and space. So let me talk a little bit about this evolution of the geospatial sensors. So today is talking about commoditization, right? So when we talk about things being commoditized, we are talking about making products, making anything uniform, making it plentiful, and making it affordable as possible, right? So let me give you two examples, which I think all of us is very familiar with, which is related to this. Personal computers in the past and mobile phones in the past used to be for very special group of people. Computers used to be cost tens of thousands of dollars. Mobile phones, thousands of dollars, right? Not everybody can afford it. Not everybody can use it or even own one at home. But today, with this going on, of course, with new technologies coming up, with new development coming up, everybody has computers not only on their home, but even traveling with them. Same for mobile phones. I'm sure for most of us here, we either have one, probably two, or even three mobile phones in their pocket right now. Right, so I think this is part of the things being commoditized. So next, let me share with you a little bit about some of the sensors that we have. In the past, when we are doing any survey work, right, traditionally we went through for angle measurements from the vernier theodolites to optical to digital. And if we need to do any distance measurement, we started with the chain and then went to EDM. Right, this is way, way, way back in the past. Of course, this technology has later merged together and formed the modern total station. Okay. So what's next after total station? All right. So FARO is again a disruptive company, and this disruptive thing again is in line with the key topic we talk about today, which is revolution. Right. So when we talk about revolution, we are talking about making massive changes, disrupting the norm. So FARO does that. Okay, we look at the technology that is available today and disrupt it. So looking at the total station, we have moved on to look at the early terrestrial laser scanners. And for some of you may have seen it, that we later launched or designed a new compact 3D laser scanner that is available today. So we're talking about from point-to-point measurements in the past. Today we're talking about the ability to do millions of points or up to 1 million points per second for scanning. All right. So this just show you an example of the changes. This is a scanner in the past, all right? That's not too long ago, probably less than 10 years ago. You have a whole table load of stuff, accessories, laser scanners, batteries, etc. These are bulky, all right? Very heavy to carry around, very expensive, and the setup is very, very, very difficult. Just imagine trying to put everything on the table here into something like this. All right, it's not easy to do so. All right, you need someone that is very familiar, very technical to be able to do this. Okay, and what we have done, okay, this is a laser scanner today. Right, from the one table load of product, accessories, cables, etc. All you need is this. You may ask, how big is this? All right, yeah, it's this big. it fits into your hands. Just this. All right. So this, again, part of the technology that has been evolving as we go along. Today, the laser scanner is much lighter, smaller, definitely much more portable, and the price is definitely much more affordable, and it's definitely much more compact. Right? And how compact it is. Okay, this is how compact. Right? In the past, laser scanning or any form of measurement required a team of people, either between 2 to 5, maybe even 10 people. Today, a laser scanner can be done, or laser scanning can be done with just one person. Right? So this is, again, the evolution of how scanning has changed over the years. What a laser scanner does, it shoots out a laser beam, all right, and then it gets reflected back after hitting some objects. It gets picked up, and that stores as a point cloud. Right? So a laser scanner, basically a high-speed laser scanning for detail measurement. Right? It's produced detailed 3D images. There's a high megapixel, high-capacity camera that pick up images for colorization purposes, and you can capture up to 1 million points per second. Right? So again, that's what you heard in the video, is using infrared technology. All right? And upon contact, you get reflected back to the laser scanner, you pick it up, and the XY coordinate is being calculated and stored. Right? And it's almost a spherical view, 360 around you, and 300 degrees up and down. Right? So with the laser scanner, what can you do with it? All right, so the next kind of short clip shows you a project that was done that we actually scan a resort. This is done in 1 day, and everything is put together within a day, and this is what you can actually see. Right. Right, so these are all point cloud, where this is not photographs, this is not pictures. So every single details you see here are point clouds. You can measure them. Okay, you can zoom in, you can zoom out. Right, you can look in, you can do a lot of things with it. You can look at the level of complexity of it, okay, to see what you can do. You can do a fly through. Okay, look at the details. All right, again, I want to stress that these are point clouds. Right? These are all measurable points. Every single dot, every single thing you see there can be measured, either distance, height, etc. Okay, so all this is done within a day, right? Everything, scanning, stitching, everything is done within the day itself. Okay, so with this laser scanning technology, right, and changing the whole technology to be smaller and more affordable to use and easier to use, it actually opened up a lot of new application, and also existing application is now more diversified. You have seen some of this in the earlier from the earlier speakers, right? Some of the applications, some of the vertical markets that we are familiar with, right? What I want to share with you is that, with a lighter and more highly efficient laser scanners, we start to see application in very non-traditional ways, right? Like gaming. A lot of 3D games today actually use laser scanning to scan some of the scenes that you see in those 3D games today available, right? Some of us don't play 3D games, but I'm sure some of the kids that you have at home played that, right? So many of those are actually captured using 3D scanners. Film and movies, okay, this is getting more popular. What you see there is a clip from the scene Life of Pi, right? So part of the scene, the boat was actually scanned using the laser scanners, and this get incorporated into the movie itself. So this kind of open up new applications, basically, for us. And what Sanjay was talking about, it also allows us to branch and expand and diversify into other industries, such as forensic industry and historical preservation. Okay. So what is driving this commoditization to bring this technology down to be accessible to everybody? I think the first thing which everybody knows is pricing, right? There's no point talking about advanced technology, huge infrastructure, when the price and the availability is out of reach for most of us. So pricing is definitely one key drivers towards getting this done. I mean, mobile phones and computers is actually a great example of that. Next is accuracy, right? We are still in a professional measurement or imaging kind of environment. If the accuracy is not there, all right, you can make it as cheap as you want, but if it doesn't meet what the industry needs and want, it doesn't make sense at all, right? So the accuracy of that product is still very essential for this. Next is mobility, right? We need to make the product, again, mobile, so that you don't need one big installation of product. You just need one product that can be moved to different projects, moved to different installations for different purposes. So you don't need multiple products for that purpose. And lastly, of course, we need to make it easy to use. When we talk about commoditization, we're talking about bringing this technology down to something that everybody can use easily. So the ease of use is important. We don't spend hours and hours to train somebody, and then that guy is the only expert in doing or using this technology, right? We want this to be able to be used by most people. Right, so part of what FARO does is that we kept thinking about new innovation, bringing innovation, trying to bring customers' ideas in so that we can develop new products, right, basically for the rest of us. So the next few slides I want to talk about is maybe some examples within the laser scanner field, right, how commoditization has really helped us. Okay, these three pictures you see here are in the past, right, how we gather data and how we use those data. So from simple sketchboards, paper, we move on to using simple software like Excel to collate our data, to share our data, right, to do calculations. And then after that, we start to have complex softwares. Okay, we have developers designing or developing softwares for different purposes. But these are very difficult to use, or they are not sufficient, or they are very complex, right? Not easy to use for some of these softwares or some of these measurements. You need skilled people to do this, right? And sometimes, we hope that we have people like this, right, to help us with some of these calculations. So today, what do we see, right? All these things has already moved away. I'm sure many of us here is familiar with this picture here, all right? It's a screenshot of either the Apple store or the Google I store, right? That you can go in there, look for apps that you need, you download it, and can use it. And the good thing is many of this is available with you, right? Either on your mobile phones, your tablets, your iPads, your personal computers. So having these apps actually make our life easier. Why? Because they actually take the complexity of all those software calculations, all the detailed calculations that you need to make, right? You put that behind an app. One touch, right? Intuitive to use, and whatever you need to be done is easy to get done, right? So this app has already helped us really to make this technology basically easier to use today. Right? So companies today is actually jumping on this same platform, right? Companies like FARO, we are doing the same thing, providing a lot of apps for very specific tasks. So today, if you need to do a calculation, you do need to do distance calculation, everything you can get it done through applications. And many of companies, as I said, is developing this, and they are actually open platform, and developers can actually develop and then put their apps to be shared, all right, with different people around the world. So I think this is part of commoditizing this whole technology, making this available, making it cheap. In this case, something even free to use, right? And make this uniform so everyone can just use it easily. The next example I want to show to you is this, all right? This series of pictures that you see here is, I think, a sequence which many of us are familiar with, right? When you need to do a project scan, you start with preparation, then you need to do scanning, and then registration. Just like what a lot of speakers have shared with us today, right? This ends up with a lot of data, right? Many of this comes out with a lot of data, right? That needs to go somewhere, right? So in most cases, this get uploaded, right? Go uploaded, and in the old days, this get into a server system. You put into a hard disk, you put into a server hard disk, so that somebody else somewhere can access to this data. They will extract it, they use it, and so on, right? And on the other side of the table, we have people receiving that data. Okay. Many of these data can be very complex, can be a lot, can be difficult to get. And to get access to this server system and so on are very expensive. For those that's in the ICT environment, you will know. Having a server infrastructure to support terabytes of space, okay, these are very expensive, costing a lot of money, or money that, well, not really go down the drain, but really spends. Why? Because the purchase, the setup, the maintenance of that is expensive. Sometimes the data is not sufficient, you need to go back and do a rescanning again, right? And then that may result in long project time. So all these are money. So some of us have seen the earlier presentation regarding the cloud. I think the cloud is another good example of this commoditization of technology, right? Today, more and more of us are using the cloud technology. The cost of cloud storage has also come down tremendously, and that making the use of cloud, more affordable and more easier. And I think more and more people is jumping on this to use the cloud, basically to eliminate the need of server, right, and to save a lot of cost for us. Yet, all right, we are not compromising or sacrificing the ability to do our work. You still allow us to share 3D scan data. You still allow us to conduct measurements, manage various projects, and then in many cases, you can actually use your mobile platforms, your mobile devices to access this data. Okay. Right, FARO has a similar product called the WebShare Cloud that actually does this, and we just call it WebShare Cloud SYN, and it's basically information on hand anywhere, right? So I want to show to you a case study here. It's actually a heritage preservation of a temple, right? So what is being done is that this service provider of ours, he actually went to a temple and scanned the whole place, right, as a project. And then this information is then loaded on the cloud, and then it's being shared and made accessible, right? So this is being shared, can be made accessible by the various internal departments. It also can be shared with the customers, the clients, and also can be shared publicly, right? So let me run through this. It's a kind of video, so we can take a look at it. All right, so first up, you see on the left, these are the various projects that's available. So this is how you manage the different projects. You pick the one that is of interest to you, or the project that is currently in discussion. So you click the one you want, all right, up pops the one on the right, which is an image of where the different scan stations are for the temple. Right? Each of those yellow dots represent a scan image for the whole place. So as a project manager, he may not be on site, all right? He might be in the office. And looking at the scan stations, he can actually know whether is the coverage good enough. And by clicking on those individual yellow dots, right, you can actually get access to some of the images you see there, which are actually point cloud images. And here what you see that you can even do calculations just using the cloud facilities. All right, again, you don't need to be on site. You can just do it here. So this can be shared with, example, again, the project manager or some whoever needs this data. All right, so you can measure it, and if you find something is wrong, this can be communicated back to the team on the ground and say that, hey, you need to make another scan somewhere. All right, so what you see here on the bottom, these are again a cloud image, all right, colorized image, for them to actually see is there any missing data that that we meant to rescan certain areas. So you can zoom in, you can zoom out, you can look at all these things. So these are again all point cloud data. Okay, these are not picture. Right? So this part of the whole historical preservation project that we can actually use not only laser scanning technology but also web share cloud technology to help us in our work. And all this is definitely not possible if not for the cost of the laser scanning and the cloud technology being brought down to a level that's affordable to most organizations. Right. So I think as what I just mentioned, right, as the cost of technology continue to fall, this become more available, it become more affordable, right? More people can actually use that. And now the next step is, since now technology is now more affordable and available, right? The next step is to look at how can we combine different technologies together to form customized solutions, to form new solutions. So one idea that we had was what we call the autonomous scanning solution, okay, which combines three concepts, or three technologies: the imaging technology, the mobility technology, and the automation technology. So when we talk about imaging, we are talking about sensors, right? A laser scanner is a sensor. So we look into that, and that combines with mobility, which is we are looking at a platform, a vehicle, right? Something that can move to bring the solution around. And the last part of it, the automation part, right, which is providing intelligence to the whole solution. The solution that can do measurement feedback, control the whole solution, report back, make corrections, and so on. Okay? So we took these three kind of concepts, technologies, put that together, and we came up with this idea of autonomous robot. So we can take a look at it, how it's being done, all right? So on top of that, you can see there's a laser scanner mounted onto a kind of a robot, all right? There's a Kinect sensor in the front. So it's pre-programmed to stop at specific places, stop and do a scan of location, right? And then once the scanning is done in one location, you'll move to the next location. But then this is where the intelligence comes in, right? It's trying to get to the next location, but we have this guy trying to block it, right? So the sensors provide the feedback and try to avoid the guy, and then so they can go to the next station to conduct the next scanning. So where's the advantage of this, right? This can be done in, example, hazardous locations. You have a plant somewhere that has, there's probably unknown danger in it, or it's hazardous that no human beings can get in there. Something of this solution is actually useful for us to actually do that scanning job for us. Or if you need to do maintenance of a plant, right, you need to do a regular scanning of locations, this can be done at night when nobody is around, and you don't need an operator to be around. Okay? So this is just to show you the red dots is exactly where the scans are, and they actually managed to scan this whole place relatively quickly. And that's just one idea, all right? It's not stopping there. I'm sure many of us here are smart people, right? You can think of using different technologies because the technology cost has now come down and it's now made more available. These different technologies have now can be combined together and form new solutions, right? Whether it's a flying solution, right, a sea solution, land-based solution, mobile mapping, and etc. Okay, the next disruptive. So laser scanning is done. All right, we have laser scanners. We have one of the smallest laser scanners, one of the cheapest laser scanners in the market, and we have tons of applications that can use that. But what's next? Right, so FARO, again, as a company that likes to think out of the box, change new things, we again disrupt. Okay, and what we have done, we're now thinking of putting laser scanning in your hands. Right? So this concept came out in the early days where we were thinking to use our FARO Scene software, combine that with the Microsoft Kinect sensor. Right? For those of you that have an Xbox sensor, right, the long bar thing, there's a Kinect sensor. So putting these two together, you're actually able to form a very simple, well, not very high resolution, but a handheld scanner. All right? It's very easy to use. It's very, very cheap, very flexible. Right? So this is what you can actually do with it. Right? You can actually scan somebody's face for fun. And this is actually being done. We actually offer that software for free. So we have a lot of feedback, a lot of people having fun with it. But it's not a product that can be used in our professional world. Right? We need something better. All right? So what do we do next? All right? So FARO took that idea and evolved that to a new generation handheld scanner, right, which we call the Scanner Freestyle. Right? Now it's a higher precision laser scanner that can carry around, okay, and do scanning. Again, it's very simple to use, flexible, lightweight, and the accuracy is up to almost 2 millimeters. So this is, again, a new concept that we came up with, and it's just launched less than a month ago, which you can see that at our booth, right? And this, again, the continuous commoditization of the technology, all right? Again, as technology gets cheaper, we can get things like this, right? This product is now a fraction of cost of a laser scanner, right? So again, they put laser scanning into your hands. Okay, the next portion, which I promised Sanjay I'll talk about a little bit about forensics. I think forensic studies is a very interesting one. Forensic study, we always think about crime scene, right? But forensic study doesn't stop at crime scene. We talk about accident reconstruction, all right? After a major accident, we want to capture the entire accident scene so that the, investigators can investigate where the cause of accident comes in. Can we improve the safety of the vehicles, right, and so on. After a major fire in a building or a building collapse, we want to scan the whole place to find out what's the cause of the fire, what's the cause of the collapse. Can we improve on the design? Can we improve on the fire safety to make sure it doesn't happen again? So this is all part of forensic studies, right? So don't go away with thinking that forensic is just crime scene, right? Although crime scene is always the most interesting part. So when we talk about the laser scanning technology, we're talking about 3D digital data, right? So being 3D digital data, the biggest advantage here is that this can be shared easily, all right? And it actually replaces the old way of collecting data on the ground. I'm sure many of us have seen police movies, right? After a crime scene, what happened? You have a big team of detectives coming on the ground, right? They try to spot where the evidence are, like where the gun is, where the knife is, where the body is, where the bullet shells are, and then they put the little numbers cards on it, right? 1, 2, 3, 4, 5, and take photograph. The disadvantage of this is that it requires the skill of the detectives or the officers on the ground. If visually they do not see or they miss out something, it's lost, right? And having many people walking up and down the place, another disadvantage is that evidence may get destroyed, right? Because if they don't see, say, a bullet shell on the ground and they step on it, that goes in the mud and then it's lost forever, okay? And this is what the old ways or the traditional ways is not helping. So 3D scanning or laser scanning, what it can do is you actually put the scanner on the ground and you can take an image of the whole place. Every detail is captured, right? And then there's no interference with the ground. There's no interference with the evidence. If the bullet hole is there, it's there. If there's a blood is there, it's there. It's captured. Sure. Right. So all this can be later sent to an expert, forensic expert, for them to look into all this and then make further studies and analysis. And these experts need not be on the ground. Again, he can use the cloud technology to look at all this data. In closing, I think what I want to say is that with this commoditization of technology, right, results such as what you're seeing on the screen is now being made available and within reach for most organizations. It's no longer something they need to spend millions, thousands of dollars, need to recruit very experienced service providers to provide this. You can actually do this on your own, right, with the cost of the product coming down, cost of technology coming down, right? So with this, I thank you for your attention, right? Feel free to visit our booth next door, right, under the FARO booth. Thank you.